In this video, we're going to look at the function y equal tangent x. It is important to remember when we're looking at this function that this is the same as the function y equal sine x over cosine x. So that we are going to start by graphing both sine x and cosine x. We've done both of this before, so I'm just going to quickly graph sine x and cosine x. For sine x, I'm getting a graph that looks like this. And for cosine x, I'm getting a graph that looks like this. And so when I'm graphing the tangent x, whenever cosine x is 0, that's not going to be defined, so that's going to correspond to vertical asymptotes. And whenever sine x is 0, that's going to correspond to whenever sine x is 0, that's going to correspond to a 0. So I'm getting zeros here, here, and here. And so if I've got my zeros at these points, then and if sine x and cosine x are both positive, I'm going to be moving in the positive direction. And if they're equal to each other, I'm going to be at 1. So I'm going to get a point right here where they cross over each other. At this point right in here, they're equal to each other, but on opposite sides of the axis. So I'm going to get -1. Here they're equal, so I'm going to get a +1. Here they're equal. At this point, they're equal, but on the negative side, so I'm going to get a -1. And so my function, my graph is going to look like this. And that's, in red, is what the tangent function looks like. The domain of the tangent function is all values of x except for when the cosine is equal to 0. So that would be all values except for pi over 2 plus k pi for integer k. And that means that we have asymptotes of x equal to pi over 2 plus k pi for integer values of k. Our range is going to be from -infinity to infinity. And our period, well, we start repeating every pi. The distance from one asymptote to the next is pi, and that's where we start repeating. So our period is pi.